do two different things. We're going to graph exponentials and we're going to solve it. So you should have a cutout. One of the cutouts has all of this information on it, so you don't have to write it down. So you can go ahead and just glue that one down. And there's a few important key characteristics that I want to point out. Who remembers AH and K? All right, so AH and K. So a couple of things. First thing I want you to notice, and I'll give you all another 30 seconds to glue that down. Since our quiz is Friday, we gotta move. Okay. So, couple of things. Your H is always going to be in your exponent. So H is in the exponent. I'm gonna write that here. H is in exponent. Because that's a good thing about you all being my third class is I know the things that people struggle with. So that's the first thing. You always flip the sign of H. The A value, A is multiplied by the base. So in this example, it could be here or it could be here. And then lastly, that K value, K is added to the equation. K is added. Now, the K value, the purpose of me writing it twice is so you can see sometimes the K value is in the back. You see how in this example it says plus K? But I think in your book, K is in the front. It starts off with K and then goes on to AB to the power of X plus H. All right, exponential functions. They all have a horizontal asymptote. The horizontal asymptote is at y equals K. Can you write that this is always going to be your domain? If it's exponential, this is your domain. So that's 1 point we should all get on Friday. The domain is negative infinity to infinity. Now the range will change based upon the A value. So if A is a positive number, then it's going to be K to infinity. But if A is a negative number, then it's going to be negative infinity to K. So the steps to graph will be, we're going to start out by making the parent table. And the parent table is going to change depending upon the base. And then we're going to apply the transformations. Now, when we apply our transformations, it is always X plus H and Y times A plus K. Does that sound familiar? Some people say, hello, X, transformations make me want to yak. One of the teachers says that to help people remember that. Okay? All right, so I'm going to give you a 60 seconds. Go ahead and copy this down. This is the equation that we're going to graph. And we are going to answer all of these questions. We're also going to write one more thing. So I'll give you a moment to situate. We're going to write, is it increasing or decreasing? And then we're also going to write the interval. So I'll give you about 2 minutes to get your paper situated. And we have 4 graphs that we're going to do all together. All right, so we know our domain. We can fill that in right away. Let's go ahead and fill that in because that's going to always be the case. Okay, so we're going to start off with y equals 2 to the power of x. That's my base. That's the parent table, I should say. So I'm going to go ahead and you choose your x value. So I'm going to pick -1 to 3. So it's called an exponential because we're changing the exponent. So I'm going to help you get through this so we're not wasting our time with a calculator. Just curious, does anybody know what 2 to the power of -1 is without a calculator? One half. So 2 to the power of -1 is 1/2. If it was 3 to the -1, it would be 1/3. If it's 4 to the -1, it would be 1/4. Anything to the power of 0 is what? 2 to the power of 0 is what? 1. 2 to the first, 2. 2 times 2, 4. 2 times 2 times 2, 8. That's my parent. Okay. Now, what changed? Now, I want you to look at this function. So my a value is in front of the 2. We don't see a number, so that means that a is 1. H is always in your exponent, but you flip it. It doesn't matter what kind of function it is. You're always going to flip h. So would h be +3 or -3? +3. And then we don't see a number being added, so that means that k is 0. So when you apply your transformations, we're going to take the h and add it to x, the y and multiply it by a and add k. So for this example, I'm adding 3. And then for my y values, I'm multiplying by 1 and adding 0, which will not change your y values. Do you agree that anything times 1 plus 0 is the same? So these 5 numbers won't change. The only change is going to happen in your x. So go ahead and make a separate table. And you're just adding 3. So you got 3 plus -1, 3 plus 0, 3 plus 1, 3 plus 2, 3 plus 3. And it's always in order. So your domain will always be in order. So now instead of starting at -1, I'm starting at 2. And then it's 3, 4, 5, and 6. Your horizontal asymptote will always be at y equals k. And what did we say k was for this example? 0. So I'm going to draw in. That means it's just my x-axis. I still like to draw mine in just as a reminder that the graph should not touch or cross that point. And then after you do that, go ahead and sketch your 5 ordered pairs. Just do the best you can. that's what it should look like. Your range is going to be k to infinity. So your lowest y value is 0. It's never going to be 0. And it goes all the way up. Now, this is really important though. It will never be 0. So do you think I'm putting a bracket or a parentheses on the 0? Parentheses. Because it will never equal 0. It'll get really, really close, but it won't be 0. Now, if you don't have the y-intercept in this table, then don't worry about it. The definition of y-intercept is the y value when x equals 0. So do you see that in our table, we don't get to x equals 0? So for this one, we're just going to cross it out. Our y-intercept is some really small number, like 0.00002. So we're not going to worry about that. We're going to just put a line on that for today. Now, let's look at the graph. Now, you really can't see it, but if you look at the graph, you see how I have my little pointer? This looks like it's constant, but it's not. It's just increasing at such a small rate that you can't see it. Now, when you get to the end, though, you can really tell that this is increasing. So you're going to circle that this is an increasing graph, and it's increasing across your domain. Alrighty. Go ahead and get your paper situated. I have some more. I'll get you one. So go ahead and set it up. So it's the same questions. If your glue stick is empty, can you just throw it away, please? Or give it to me and I'll throw it away. All right, what's the base for this function? What's our base? Base of the exponent. 3. That's the number attached to the x plus 2. That's called our base. So the base is 3. I'm going to quickly make my parent table, which will be y equals 3 to the power of x. Now, because my base is bigger, I can't go as high. Because remember, we have a 10 by 10 grid. 3 to the third is 27, so that's too big. So what do you think 3 to the power of -1 is? 1/3. And then 0 to the third, I'm sorry, 3 to the 0 is 1. 3 to the first is 3. 3 to the second is 9. So this one has a lot of transformations. So we got a lot of changes happening. This is my A value. A is 1/2. My H value is in the exponent, but you flip it. So it's not going to be +2. It will be -2. My K value is the number that's being added. And in this example, it's -7. All right, so a couple of things I can fill in is I have a horizontal asymptote at y equals -7. And I know my domain immediately. I can fill those in. So I'm going to draw that in. 1, 2, 3, 4. Draw in my horizontal asymptote. And whenever you do transformations, it's always H plus X, Y times A plus K. So this time we got changes happening on both sides. So my H is -2. So you're going to add -2 all the way down. And then on the Y side, I'm multiplying that by 1/2. And then I'm adding the -7. And you're going to do that all the way down. So I'll give you a moment to come up with your new table. I'm going to freeze my screen and you try to find yours. You're going to have a lot of decimals in the Y value. That's okay. We'll do the best we can. So I did mine from memory because this is my third time doing it, but make sure that that's right. Got some confused looks. Did I mess up something? Hold on. 3, half of 3 is 150. Yeah, I think they're right. I'm gonna say they're right. I don't know. All right, let's go ahead and graph it out. So that first point is right above my asymptote. You really can't graph that, you know, because it's not gonna look. You can't graph a decimal really. And then at the -2, I'm here, and then at -1, I'm at 1. I'm here. And then this one, we actually do get a y-intercept. So I'm gonna connect it, and then because of that 1/2, that's making it go up really slow. So A is positive. So my range is going to be -7 to infinity. Do I put parentheses on both sides, or do I put a bracket on the negative 7? What goes on the negative 7? Parentheses. And this time, our table does have the y-intercept, so we can list it. So right here, that would be my y-intercept. And when you look at this graph, looking at the end, what is it doing? Is it going up at the end, or is it going down on the end? Up. So this is increasing. It's not decreasing. This is increasing. And it's increasing from negative infinity to infinity. And that is example 2. All right, let's go ahead and get your page set up for example 3. I am changing it a little bit though. So yeah, I already changed it. Okay. So we're going to do y equals 1/2 to the power of x plus 1. Don't forget you have a new math review posted, and then that 5.1 assignment where you have to watch the video, that's closing soon. So I'll send out another reminder to those who haven't submitted it. All right, so don't make your table. We're going to do our table together. Because it's 1/2, and I'll explain this when we get to it, we're going to use negative numbers. We're going to use more negative numbers than positive. So my x values that I'm going to use are -3, -2, -1, 0, and 1. And I'll explain why that is. If you take 1/2 to the power of -3, this is just a little mini algebra 1 review. If you take 1/2 to the power of -3, that is the same thing as 2 to the power of +3. The way you make an exponent positive is by taking the reciprocal. So 1/2 to the power of -3 is the same as 2 to the power of 3, which is 8. And then moving down, I'm just dividing by 2 over and over again. So if I start with 8, what's half of 8? 4. What's half of 4? 2. What's half of 2? What's half of 1? 1/2. That's my parent. Now, when you compare this to this, you compare this parent table. My laser doesn't want to write all the time, but when you compare this one to this one, there's only one thing that changed. Is it A, H, or K? Which one changed? K. So in this example, the number in front of the 1/2 is 1, so A is still 1. There isn't anything in the exponent besides X, so that means that H is 0 and K is 1. So the only transformation, we don't need to waste time by adding 0 all the way down. That's not going to do anything. So our domain doesn't change. for our y values, we're multiplying it by 1 and adding 1, but the only thing that will change it is to add the 1. So let's not waste time by using a calculator. We can add 1 to 8 without a calculator. So I'm going to make my second table. This is the table that we're actually going to graph. My domain doesn't change. And then I'm adding 1. 8 plus 1 is 9. 4 plus 1 is 5. 2 plus 1 is 3. 1 plus 1 is 2. 1/2 plus 1 is 1.5. So let's go ahead and graph that out. I'm going to write down my horizontal asymptote. Y equals 1. I'm going to draw that in. And then I'm going to graph it. So because A is positive, it's still going to be, my lowest K value is 1. It's never going to be 1. And it's going up to infinity. We do have our y-intercept in our table again. So my y-intercept is 0, 2. I can put that down. All right, so now looking at the screen, what does it look like it's doing here? If you look at the laser, everybody look at the laser, what is it doing? Is it going up or down? Down. So this is decreasing. The reason why I didn't pick numbers over here is that my y values are super small. It's like 1.2 and then 1.1 and then 1.11. So that's why you want to use negative numbers so you can actually get points that you can graph. So you would say this is a decreasing graph. So this is decreasing. And if you haven't figured it out already, the interval is always your domain. All right, we only have one more. Go ahead and set it up. I'll put up the equation in a second, but you already know we're going to do domain, range, horizontal asymptote, y-intercept, decreasing or increasing. Does anyone need more time with example 3? All right, this is our last one. So this is kind of tricky because some people may see this negative and think my base is negative 2. The base is always positive. My base is just 2. So my parent is y equals 2 to the x. That negative in the front represents your A value. So we've been doing this table a lot. We probably know it by heart. If not, you will, because we use 2 a lot. That's my parent. And when I talk about the transformations, I'm saying comparing this to this two things change when I compare this one to this one. So we already know that the A changed. A became -1. What is our H value? Yep, if you look in our exponent, it's just a X, so that's 0. And what's my K value? 8. All right, so it's going to be no changes to X because we're just adding 0. But over here, we're multiplying it by -1, and then we're adding 8. So I'll give you a second to create your transformation table. I'm going to freeze my screen, put up my table in a second. I want you all to try. Okay, so now I'm going to go ahead and graph this out. So at the -1, I'm right under the asymptote. And then I have my y-intercept, 0, 7. And then 1 is up 6. And then 2, we go up 4. And then 3. Okay, wait, I skipped something. 2, we go up 4. And then 3, 0. All right, so this is the first time where we had a negative A value. So what is our lowest Y value? See how we have an arrow pointing down now. So that means my lowest Y value is coming from -infinity. So my range is going to be -infinity to 8. We have our y-intercept again, so we can fill that in. All right, so let's look at the tail. What's happening to it? Is it going up or down? Who says it's increasing? Who says decreasing? It is decreasing. So we're going to say this is decreasing. It has a decreasing interval. And it's decreasing from -infinity to infinity.